Hello students, good morning. Welcome to today's physics class. In the last class, I have discussed about projectile motion. What do you mean by projectile motion? When an object is thrown in the air with some initial velocity and then allowed to move under the action of gravity alone, the object is known as a projectile. The path followed by the particle is called its trajectory. Some of the examples also I explained. That is a ball thrown in any direction, a javelin or shot put thrown by an athlete, etc. This projectile moves under the combined effects of two velocities. That is a uniform velocity in the horizontal direction. There is no change in this velocity. Also, uniformly changing velocity in the vertical direction. Then the types of projectile. There are two types of projectile motion. One is horizontal projection. Second one is angular projection. What is meant by horizontal projection? Projectile given an initial velocity in the horizontal direction. That is, from top of any building or tower, we are throwing the object horizontally. That is horizontal projection. Second one, angular projection. Projectile given an initial velocity at an angle to the horizontal. That is angular projection. That is, in the ground, we are throwing a ball to a front. So here, with the horizontal direction ground, we are throwing the ball at an angle theta. That is angular projection. Yesterday, we have seen the projectile in horizontal projection. Isn't it? Projectile in horizontal projection. In that, we have discussed about motion along horizontal direction, motion along vertical direction, time of flight, horizontal range, resultant velocity, speed of the particle, etc. We got the formulas like this: y equal to kx square. That shows the equation of parabola. And the time of flight t is equal to root of 2h by g. Time is directly proportional to the height. And the range r equal to u in the root of 2h by g. And the speed v is equal to root of u square plus 2gh. I think you all have learned this question. If you learn this question, if you understand this question, you can understand the next angular projection very easily. Today's topic is the second type of projectile motion. That is projectile under an angular projection. Projectile under an angular projection. The projectile motion takes place when the initial velocity is not horizontal but at some angle with the vertical. That is, when you are watering the garden with a hose, the water flowing from that hose is an example of angular projection. Water is ejected out of a pipe. Similarly, cannon fired in a battleground. That is also an example of angular projection. So, angular projection means in the ground we are throwing. So, we are throwing the particular object which makes an angle theta with the horizontal direction. This angular projection can be called as oblique projection. Oblique projection or oblique projectile. So here, consider an object thrown with initial velocity. So this is the ground. You can choose this as an x-axis. This is the y-axis. An object is thrown with initial velocity from this this object moves like this. The initial velocity is u. So this object goes up, it reaches the maximum height and it undergoes the action of force of gravity and it reaches the ground. Here, this is an angle theta. Okay. So, object thrown with initial velocity u vector at an angle theta with the horizontal. Theta with the horizontal. Now, this initial velocity can be written as ux I cap plus uy j cap. That is, it can be resolved into two components. One is along the x direction, that is ux, and another one is along the y direction, that is uy. So at every point here, the ux is acting here and uy is acting here. At this point, it reaches the maximum height. Here, this is ux. Here actually, the uy value is equal to 0 at this point. And here, this is ux and this is uy. So this is the path of the projectile. This we can consider as the maximum height, h max. Okay. This is the graphical representation of an angular projection. Now, this x component of the initial velocity we can write as ux is equal to u cos theta. And the y component of the velocity we can write as uy is equal to u sin theta. This already we have learned in the components of vector. So this vector can be resolved into along the x component x ux equal to u cos theta and along the y component or y direction uy equal to u sin theta. And in the projectile motion we have an assumption there. It has the uniform horizontal velocity and the vertical velocity gets changed. Since the acceleration due to gravity is in the direction opposite to the direction of the vertical component, this component uy, that is a vertical component, gradually reduces to 0 at the maximum height. This vertical component of velocity reduces to 0 at the maximum height. At this maximum height, the gravitational force will push the projectile downward and fall to the ground. Here there is no acceleration along the x direction throughout the motion. Okay, no acceleration along the x direction. Also I said that this ux equal to u cos theta remains same till the object reaches the ground. Now let us see the kinematic equations and find out the horizontal distance, vertical distance, etc. So, the velocity along the horizontal motion. The velocity along the horizontal motion. How can we calculate? We know the equation v equal to u plus at. This is the first kinematic equation, velocity time relation. So, velocity along the horizontal motion we can write vx is equal to ux plus ax into t. Here vx is equal to ux is u cos theta, isn't it? U cos theta plus what is ax? I said there is no acceleration along the x direction. So ax is equal to 0. So we can write vx is equal to ux, that is equal to u cos theta. So Vx is equal to ux, that is equal to u cos theta. This is the velocity. Now what is the horizontal distance? The horizontal distance travelled by the projectile in time t. For this, we should use the displacement relation. What is the displacement relation? S is equal to ut plus half a t square. So here horizontal direction means we can use Sx is equal to uxt plus half ax t square. What is Sx? Sx we can consider here as x. So here consider this point P. After a particular time t, the ball or the object may reaches this point P. So what is the horizontal distance? That is, this distance is the horizontal distance and this distance is the vertical distance, right? So x is the horizontal distance at any time t. So Sx is equal to x and we know ux is equal to u cos theta and ax is equal to 0. So how this equation can be written? That is, the horizontal distance travelled by the projectile in time t is Sx x is equal to ux u cos theta into t plus half ax is equal to 0. So it is equal to 0. So x is equal to u cos theta into t. From this we can write t is equal to x by u cos theta. Okay. So this is considered as equation 1. So in this oblique projection or angular projection, first we have seen the horizontal component of velocity, that is Vx is equal to u cos theta, then horizontal distance travelled by the projectile. Okay. Now let's consider the vertical motion. So in vertical motion, what is the vertical component of velocity? Same. Vy is equal to uy plus ay into t. Uy plus ay into t. So what is uy? We know uy, that is the y component of velocity is u sin theta. What is ay? Ay is equal to, that is acceleration due to gravity acts opposite direction of motion. So we can write minus d. We are throwing the ball. So acceleration due to gravity is acting downward. The ball thrown is acting upward. So ay, vertical motion, we can write the minus d because acceleration due to gravity acts opposite to the direction. So how can we write this equation? The vertical velocity Vy is equal to u sin theta, uy u sin theta minus g into t. This is the vertical velocity. Then what is the vertical distance? Vertical distance travelled by the projectile in time t, that is Sy is equal to uy into t plus half ay into t square. So what is Sy? This is the vertical distance travelled. We can consider as y. Then uy is u sin theta. Then ay, that is ay equal to minus d. So we can substitute here y is equal to u sin theta into t. Y is equal to u sin theta into t plus, here a equal to minus d, so here minus half g t square. This is the vertical distance. So substitute the equation 1, that is t equal to x by u cos theta. T t equal to x by u cos theta. Substitute this equation in equation 2. This is equation 2. So how can we write? Y equal to u sin theta into what is t? T equal to x by u cos theta minus half g t square. T square is x square by u square cos square theta. X square by u square cos square theta. So substitute equation 1 in equation 2. We got y equal to u sin theta into x by u cos theta minus half g x square by u square cos square theta. We can simplify this. Sin theta by cos theta is tan theta. U got cancelled. So x tan theta minus half g x square by u square cos square theta. So this is also the equation of parabola. So the path followed by the projectile is an inverted parabola. The path followed by the projectile is an inverted parabola. You may have learned parabolic path. This is the parabola. So here we are throwing the object in the horizontal direction at an angle. So this is like in this manner. So this is called the inverted parabola. So this equation is similar to the equation of the parabola. So then you have to learn the horizontal projection first. Then only you can understand the angular projection. If you follow the first one, the second one is very easy. So first we have learned the horizontal distance and horizontal velocity. Next we have learned the vertical velocity and vertical distance. The next one, maximum height. What is the maximum height? The maximum vertical distance travelled by the projectile during its journey is called maximum height. The maximum vertical distance travelled by the projectile during its journey is called maximum height. In this picture, this is the maximum height, maximum vertical distance, h max. To determine this maximum height, we can use the kinematic formula v square equal to u square plus 2as. So vertical distance, so we can use vy square equal to uy square plus 2ay into s. Here we know that uy equal to u sin theta, that is the vertical component of velocity. Ay is equal to minus g, and s is nothing but the maximum height. At this maximum height, Vy equal to 0. What is Vy equal to 0? In this, the projectile thrown with initial velocity reaches the maximum height. So at this height, the By value is equal to 0. Afterwards, it undergoes the force of gravity, it reaches to the ground. Okay, so Vy equal to 0. Hence, this equation can be written as Vy is equal to 0. So 0 square equal to what is Uy? U sin theta. U square. So U sin theta whole square. 2Ays. Ay is minus g. So we can write minus 2g into, instead of s, we have to put h max. So 0 equal to u square sin square theta minus 2g h max. That is 2g h max is equal to u square sin square theta, or h maximum is equal to u square sin square theta divided by 2g. So this is the maximum height. traveled by the projectile. Okay. So we are using the kinematical equation. Kinematic equation v square equal to u square plus 2as. In that we are using the vertical component. Fully substituting these values, we got h max is equal to u square sin square theta by 2g. Then next, time of flight. The total time taken by the projectile from the point of projection till it hits the horizontal plane is called time of flight. The total time taken by the projectile from the point of projection till it hits the horizontal plane is called time of flight. This time of flight is the time taken by the projectile to go from this point, that is initial point, or O to A to B, O to B via A. So time of flight we can obtain by using the relation S is equal to ut plus half at square. We are using the vertical component Sy equal to uyt plus half ayt square. So Sy is equal to y is equal to 0. Why it is 0? Net displacement in y direction is 0. That is, the projectile starts from here and it goes like this and comes down. So what is the net displacement? That is, in the y direction is 0. So it starts from the ground and reaches to the ground. So net displacement is 0. Then uy we know, u sin theta. Ay equal to minus t. And the t we can written as time of flight tf. So substitute all these quantities in this relation. We get 0 is equal to Sy, that is y equal to 0. So 0 is equal to uy, that is u sin theta into tf, ut plus half at square. So what is a? Minus g into what is t? Tf square. So we can write u sin theta tf. 0 is equal to u sin theta tf minus half g tf square. We can rewrite this half g tf square is equal to u sin theta tf. So 1 tf square, tf get cancelled. We can write tf is equal to 2u sin theta by g. 2u sin theta by g. So this is the time of flight. Okay. So time of flight can be obtained from the relation S is equal to ut plus half at square. In that we are using the vertical component of displacement, velocity, and also we got tf is equal to u sin theta by g. The next one is horizontal range. Horizontal range. What is horizontal range? The maximum horizontal distance between the point of projection and the point on the horizontal plane where the projectile hits the ground is horizontal range. The maximum horizontal distance between the point of projection and the point on the horizontal plane where the projectile hits the ground is horizontal range. Here, this distance from the point of projection and where it reaches the ground. So this distance is the range. The range R can be easily obtained by the horizontal component of velocity into time of flight. That is, distance is equal to velocity into time. Here the distance is nothing but horizontal distance, that is the range. So range R equal to horizontal component of velocity into time of flight. So what is that? R equal to, what is horizontal component of velocity? U cos theta. What is time of flight? 2u sin theta by g. U cos theta into 2u sin theta by g. this can be written as 2u square sin theta cos theta by g. 2u square sin theta cos theta by g. Again we can write like this. How? R is equal to u square into sin 2 theta by g. Since sin 2 theta is equal to 2 sin theta cos theta. So instead of 2 sin theta cos theta, we can substitute sin 2 theta. So 2 u square sin theta cos theta can be written as sin 2 theta into u square. U square sin 2 theta by g. So range R is equal to u square sin 2 theta by g. The horizontal range directly depends upon the initial speed u and the sine of the angle of projection. Horizontal range is directly proportional to the initial speed and the sine of the angle of projection, and inversely proportional to the acceleration due to gravity. So here the maximum possible range. Maximum possible range. How can we calculate? The maximum possible range is reached when sin 2 theta value will be equal to 1. Sin 2 theta is maximum. When sin 2 theta is maximum, or we will be getting the maximum value. So sin value, sin 2 theta value maximum, sin value, the maximum value is 1. For sin, the maximum value is 1. So 2 theta is equal to what? Sin inverse of 1. For what sine angle? Which sine angle value is 1? That is pi by 2. So 2 theta is equal to pi by 2. Theta is equal to pi by 4. Theta is equal to pi by 4. So at this angle, we will be getting the maximum possible range. Pi by 4 means the particle is projected at an angle 45 degree. The particle is projected at an angle 45 degree with respect to the horizontal. It attains the maximum range. Okay. So R can be written as u square sin 2 theta value will be equal to 1 when theta equal to 45 degree, then divided by g. So R is equal to u square by g. This is the maximum range. Maximum range. So when the batsman in cricket strikes the ball at 45 degree, it covers a large distance. It covers the maximum range. One best example for angular projection is given in your book. That is, in Tamil Nadu there is an interesting traditional game, kitty pull. When the pull is hit by the kitty, the path followed by the pull is parabolic. Your parents may have played this kitty pull. Whether you are playing or not, I don't know. With 2 sticks, they will be projecting and they will be measuring the distance. So who is covering large distance, that person is the winner. So this is the kitty pull. This is an example of projectile motion. Students, today we have seen the second type of projectile motion, that is oblique projectile or projectile under an angular projection. So here an object is thrown with initial velocity u, which makes an angle theta with a horizontal plane. So this object goes up, it reaches the maximum height and it comes to the ground. Here this is the maximum height and this is the horizontal distance, that is the range. In this, the initial velocity can be resolved into 2 components. One is along the x-axis and one is along the y-axis, that is ux and uy. That can be written as ux is equal to u cos theta and uy equal to u sin theta. Here we have discussed in the horizontal direction what is the velocity and distance, and in the vertical direction what is the velocity and distance. In the horizontal motion, what is the velocity? Velocity Vx is equal to ux. that is equal to u cos theta because ax is equal to 0. And horizontal distance obtained from the relation s equal to ut plus half at square. So we got x is equal to u cos theta into t. From this t equal to x by u cos theta. This is the horizontal motion. Vertical motion, the velocity vy equal to u sin theta minus gt because ay equal to minus g. And vertical distance is obtained by sy equal to uyt plus half ayt square and y equal to u sin theta t minus half gt square. By substituting the t value, we got y equal to x tan theta minus half g x square by u square cos square theta. So this path is an inverted parabola. This equation is the equation of parabola, that is called inverted parabola. The next maximum height, h max. It can be obtained from the relation v square equal to u square plus 2as in the vertical direction. So h max is equal to u square sin square theta by 2g. Then time of flight. Time of flight obtained from sy equal to uyt plus half ayt square. Here the sy, that is the net displacement, is equal to 0 and we got tf equal to 2u sin theta by g. Then the horizontal range, that is the maximum horizontal distance, that can be written as r equal to horizontal velocity into component of velocity in time of flight. So r equal to u square sin 2 theta by g. When the maximum range we will get, the maximum possible range is obtained by sin 2 theta equal to maximum, sin 2 theta equal to 1. So 2 theta equal to sin inverse of 1, 2 theta equal to sin inverse of 1 is sin 90 degree, the value is 1. So sin pi by 2. 2 theta equal to pi by 2, theta equal to pi by 4. So theta equal to 45 degree. At 45 degree we will be getting the maximum possible range. So r maximum is equal to u square by g. So in this oblique projection we got these formulas. Y x tan theta minus half g x square by u square cos square theta and h max tf r max. These formula try to memorize. This will be useful for solving problems. H max is equal to u square sin square theta by 2g, tf is equal to 2u sin theta by g, r equal to u square sin 2 theta by g and r maximum is equal to u square by g. Students, you have to learn the book bag question. Derive the equation of motion, range and maximum height reached by the particle thrown at an oblique angle theta with respect to the horizontal direction. This is the today's topic. Learn well, students. Students, try to do the example problems 2.37 and 2.38. These two problems are important using oblique projection. Okay, 2.37 and 2.38. So oblique projections, horizontal projection. Two questions, write and learn. Thank you, students.